sticking with our pKa theme for our review, we're going to do part 4 of the fall 2022 test 2. And we're starting with a diprotonated acid. Now, the fully protonated here, when you're given 4 pKa's, is H4A, no, that's over here, H4A, and that's that one. What's pKa2? What's the generic? H3A minus. And then this one, H2A2 minus. And what about this one? HA minus 3. Just do that to get started, okay? You notice the 4 here matches the 4 here? See that? So I'm giving you 4 pKa's, the most protonated one and the least protonated one. So which of those 4 things am I starting with this word here? H2A2 minus. You got to start there. Here's the full ice treatment. Full ice. Bless you. H2A2 minus. What's it reacting with today? Okay, now reword it with only the part that's important. Yes, hydroxide. Yeah, sodium, I even crossed it off in the question. You know, look, I crossed it off. It wasn't there. Sodium, gone. And what is that? Is that an acid or a base? That's our strong base. On Wednesday, you're going to have hydroxide there or HCl. That's the way I roll. I'm not going to change. It's going to be one or the other. I can't remember which, to tell you the truth. So I think I made that up last Thursday. So it's too long ago. What happens to H2A2 minus when you treat it with a base? What does it become? It loses 1 hydrogen at a time, right? And it becomes HA3 minus, or minus 3. And I also made water, but I don't care, do I? I'll write it, but who cares? Not relevant. I mean, it's made. I can't lie. Numbers for my ice here. I got H2A2 minus starting at 2. I got hydroxide starting at 2.75. I got 0 of this, and water we don't deal. What's limiting here? The 2. And when you use 2, you make 2, right? So the hydroxide is not gone. That means you're not done. Hydroxide must react completely. You need ice number 2, starting with HA3 minus. Hydroxide again. And what are you making this time? Hey, we don't have this one written down yet. A 4 minus 4, same thing, right? And forget about water. So we got the 2, we got the 0.75, and we got the 0. Oh, hydroxide's limiting. Put a happy face there, right? Because you're done. 1.25 here. Oh, sorry. Plus 0.75 here. Here's your 2 species that you're finishing with. Which of those 2 is the acid? Which of those 2 species is the acid? The one with the extra H on the left. I need the number. I think you gave me a number for how much of he answered a different question. He asked how much there is. My question is, what's the pKa of that acid? There you go, 12.5. Your answer better be close to 12.5. Is it up or down? Keeping in mind, you have a higher amount of acid than base. Here's where you're using the Henderson-Hasselbalch equation without using it. Down. You have more acid than base. You just tell me it's less than 12.5. Hey, if you wrote example, 12.4. You're going out on a limb there. You don't have to, but just tell me you know it's not exactly 12.5, but it's a little below. You want to write it as a sentence? That's great. Okay? I shouldn't have, you know, pH is 12 point, I didn't give good wording at all. pH equals 12.5 down, should have been my wording. pKa is 12.5, I can't change that. Exempli, grazie. Grazie. 12.4, pH.
So you said you're lucky to have the OH minus as a remedy. What if it was not?
Well, then you're not done.
How would you continue?
Ice number 3. He asked if hydroxide was still not done after ice number 2, what do? You have to do ice number 3. But in this question, you can't do ice number 3 because you got no more protons, right? So this species would still have to have protons to be able to do ice number 3, right? And I believe yours is 2 ice problems anyway. I won't make you do 3. You want the shortcut? Here's what you do. Shortcut. You write H2A, 2 minus, 2 mole is going to use up hydroxide, 2 moles, to make HA minus 3, 3 minus, and then you do ice. You got to use your brain a little bit. Well, you always have to use the brain a little bit. So you're starting with 2, and you still have how much hydroxide? Sorry, you use 2 moles of your hydroxide to react with 2 moles of this to get this ice problem set up. If 2 moles of hydroxide are gone, you're left with 0.75. You kind of did the ice problem in your head. But it's 100%. You're done. It's over. So you don't need an ice for that. And then it's going to be minus 0.75, minus 0.75, 0, 25, 0, 0.75. And you're at the same place, right? Same answer.